Morning, Simon. Thank you for joining me. So this morning you released an update to your relationship with the University of Melbourne, and you have now signed binding documents for the exclusive global rights to their microwave technology for rare earth extraction. So congratulations on that, first of all. And can you please tell me and all of our viewers what exactly is microwave technology and why you're so excited about it?
Well, good morning, Hannah, and it's great to be with you, and great that we've managed to get to these binding documentations with the University of Melbourne. It's taken us a little time to work through from our initial term sheet, which we announced some time ago, but we've worked through all the required documentation and licensing, and it's great to be at that point today and announcing that today. In terms of microwave technology, what are we excited about? Well, look, we all use microwaves probably in our homes and have been for many years, and we know how quickly and efficiently that can help in the cooking process. Well, in the case of rare earth elements, which is what we're doing here with the university primarily, you need energy to unlock materials in these rare earth elements that have been captured in things like magnets, permanent magnets. And so what we're looking to do is use this microwave technology to help energize the materials, the recovered magnets and pre-processed magnets, to bring out the rare earth elements and allow them to be extracted and then reconstituted into oxides, which can then be repurposed into new magnets or into other applications. So what's exciting about the microwave technology particularly is that it's efficient in doing that. Compared to some of the other methodologies that are out there today, it is highly efficient from an energy point of view, using 85% less energy than what's known as hot technology that sits out there today. So really exciting that we're able to secure this agreement with the university, because we think this technology puts us low on the cost curve in the recycling end of town.
So the announcement stated that you've got some really good and really strong recovery rates from the use of the microwave technology. In some cases, that's upwards of 90 or 95%. Why are these so significant, and how do they compare to the existing recovery rates?
Great question, Hannah. These recovery rates that we're seeing from the university technology are significantly 50% better than what we're seeing out of some of the other technologies out of there. What does that mean? Again, it means high recovery rates mean you're getting a lot of material out from the material that you put in. That gives you a benefit of yield. Yield means you're lower on the cost curve. So combine that with high recovery rates, which even if they diminish as we scale the technology a little, then we're still well positioned relative to other technologies. Low on the cost curve on energy inputs to get us to those recovered rates. So really important when you think about recycling, and we think about this within our battery recycling business, is how do we make sure that in the long term we maintain a low on the cost curve position, because that's going to be a sign of longevity and success. So hence why we've done the deal that we've done with the university. It also, what's an added bonus, if you like, with the university technology, is it's showing some promising signs on platinum group metals, or PGMs as it's known in the marketplace. And we've now negotiated, as we move from term sheet into binding documentation with the university, an opportunity to extend this microwave technology into that platinum group of metals. And again, you're seeing high recovery rates in things like platinum at 90%, palladium at 95%, and even rhodium at 65%, and potential to go higher than that in that category. So really exciting about what the technology brings. Puts us, we think, low on the cost curve on energy, low on the cost curve because we've got high yields, and now an opportunity to also step that technology from rare earth elements into platinum group metals as well.
So what then is your intention on the pathway post recovery? So you've got, high yields, high quality recoveries. And then what are you going to do with it, with the supply chain?
Yeah. Look, one of the successes that we think we've got in our battery recycling business in EnviroStream is being able to solve customers' problems. And where does our strength come in? It's our core strength is being able to bring in problems for our customers, particularly in end-of-life product, where there's a recovery option, and being able to take that end-of-life product and pre-process it to get it ready to apply to a technology. We don't see ourselves as being technology experts, and that's why we've reached agreements on a range of recycling options, both in terms of battery recycling and processing our black mass, but also potentially with solar panels and now with rare earths, working with technology partners to be able to do that. So being able to bring in the feedstock, pre-process it is where our core strengths lie. And that's what we see we'll do with the technology partners like the university, add value to that pre-processed material. But then going further, we would see ourselves selling that material into someone who will, again, repurpose the materials, the rare earth elements back into permanent magnets or other applications where those rare earth elements are used. So that's where we stop. We work with those technology partners, get the value add those materials further than the pre-processed material, and then pass that on to people who are going to repurpose it back into new equipment.
Yeah, and then lastly, your announcement also states that we've got several stages as part of this, and there are some small modest fees that are attached to some milestones in there. Presuming that stage 1 is going to come first, what can we expect to see in stage 1, and when can we expect to hear more?
Yeah, look, obviously we're taking a very thoughtful, methodical way into this. We want to make sure that we can build our confidence that the technology will scale as we would expect, both in terms of yield performance, energy performance, but also what the capital requirements will be to continue to scale the technology and bring it to successful commercialization. Stage 1 is really an early piloting phase. We're providing materials into the university for them to work on. They'll be working on that at a larger scale than they've done to date to be able to extract the material at a larger rate than they have previously, but we're still talking grams of materials, not tons of materials. And that will give us then confidence to move forward into stage 2, which will be a larger scale activity. And then, assuming that's successful, we'll move into stage 3 plus, which will really be the commercialization pathway. Again, we're doing this in a very thoughtful and considered way. We're not, people shouldn't be thinking that we're spending millions of dollars on this straight out of the gate. Our first payment to the university is in total $65,000, $45,000 as we start, and then a further $20,000, and then that builds up to a potential sort of 200 with an option for us to go to 250,000 if we think that extra push will get us to the right outcome. So very thoughtful, considered process. And as you say, step through. What you should see next is for us to talk about how that stage 1 is progressing and successfully completing.
All right, thank you very much, Simon. Again, congratulations, good luck, and we look forward to hearing some more.
Thanks, Hannah, and we're really excited about where we've got to with the university. Not only have we submitted the term sheet, but being able to build in that optionality around the PGMs, but really excited about what this technology might be able to achieve.